Hey gang, it's me again. And today we're going to talk about the using the Opal Kelly memory. I have started this thing compiling right now. The couple little warning messages popping up saying that some black boxes, which are these FIFOs, a couple of wires not used right here. That's all things that are fine. We'll talk about one of the errors or one of the warnings I get here in a little bit, but when it gets to that. So over here on the left is the Opal Kelly stuff. So this talks to our USB, a wire in, a pipe in, and a pipe out, and a wire or to tie it all together. Over here off on the board somewhere is a 32 megabyte micron SDRAM, max speed 133 megahertz. So that's good. We feed in our reference clock from the PLL to this DCM that basically sets up the phase delays and everything, sets it right back out. It goes through a double data rate transfer register and out and drives the SDRAM directly. Here we have the SDRAM controller that handles auto refreshes, has our chip select, our RAS, our CAS, our write enable, the block address inside the RAM, the absolute address within a block, and then the actual data that will be going back and forth to the RAM. So the way this thing works is the application that Opal Kelly sent for the RAM tester executable. It goes out to the FPGA. It loads up the default PLL, it squirts this bit file into it, then it comes here on the wire in and asserts a reset. The reset clears the FIFOs, sets the SDRAM controller, the transfer negotiator, and the fault detector into known good states. It releases the reset and it asserts write. When write happens, the transfer negotiator says, "Oh, I'm getting ready to get data." And it goes into the waiting for, it's called write acknowledge state is what it's looking for. Okay. And that, so this DRAM controller does everything in block transfers, 512 words. Even though I keep saying bytes, I mean words. So it does 512 words out, 512 words back to get the best speed it can out of the RAM. So then in the application, it creates a big chunk of random data and squirts that data out here to the FPGA to this read FIFO. When the read FIFO has at least 512 words in it, the transfer negotiator says, "Hey DRAM controller, go transfer that data over to the DRAM." So the DRAM controller sucks the data out, spits it out to the DRAM, and this keeps going until we either deassert write. So we need to make sure that we wrote all of our data before we deassert write, otherwise we're going to have data stuck in our FIFO. Or you just, whoops, time to go to work. Or we run out of data. Or we have an error. If this thing ever underflows, I think, we get a fault detection down here, which sets an LED, but it doesn't do anything. So we should never overflow, we should never overflow, because this thing is so much faster, the DRAM controller is so much faster than the USB. The next thing the application does is it resets things again, pops everything back to known good states, and then it says read all this data back. So it put a bunch of random data in there. Transfer negotiate goes into the read acknowledge set. And as long as there is at least a full page free in this write FIFO, it sucks the data back into it, and the write FIFO squirts data back out to the pipe out. If it ever gets up where it's not, it stops it, goes into an idle state for a little bit, waits again, and everything goes back. Back in the application, then the two are compared, and it basically says, "See, my RAM worked." There's a question I have about that because the default for this board is 50 megahertz. I've looked at the SDRAM controller, and it still seems to work, even though it's operating at 50 megahertz. It's sending out auto refreshes that are too slow by the factor of about 2. Or I should say maybe they're going out half as often as they should to meet the minimums in the data sheet. So I'm curious about what's going on with that. It might be that we're operating really close to broken. But we finished our compilation, synthesis, programming file. We have a couple of warnings. My FIFOs I used block RAM, and it's complaining that there's a parity bit on the output that's dangling, that the devices are set up to use parity. I didn't tell it to, so that maybe that's something about the block RAM by itself. It's telling me a bunch of pins not used, whatever. It's telling me that it couldn't merge a mux for, it looks like it's an F5 mux is what it says. So there's a conflict, and I'll have suboptimal timing. I'm not too worried about that right now as long as it works. And that's what the warnings are. So we've just created memory.bit. So we'll come over here and find memory.bit right there. And I will copy it over to my directory where I have RAM tester. Now, ramtester.exe, right here, have to have the OK front panel DLL in the same directory, and your bit file must be named ramtest.bit, otherwise nothing will work. And double click this, and right off the bat it's telling me front panel DLL loaded, found a device, firmware, serial number, blah blah blah, front panel support enabled, generating random data, writing to memory, reading from memory, and they're all passing. So passed 5, passed 6, passed 7, failed 0. So everything's merrily writing out there, merrily coming back. I've verified that I am using a 50 megahertz clock, not a 100. And that's it for today. So we have RAM working, and I'm maybe going to do some experimentation from here. Bye all.